Hi, week 1, day 7, word pattern. Okay, we're given a pattern and a string. You have to find out if the string follows the pattern. So you might know that some poems are there and there are some patterns like A, B will mean that the alternate lines rhyme or something. Basically, look at this A, dog, cat, dog. They follow the same pattern, okay? Wherever there's a dog, there's a A over here, and wherever there's a, there's a dog over here. So I can make a good match between these two, dog and A. That's all there is to this part. Then let's look at this next one, A, dog, cat, fish. Now note that A has already been mapped to dog. So when the second A comes and they say fish, the pattern has failed, right? You can look at this over here. So that's yesterday's image overlap. Great problem. Even today's problem is actually just implementation only. You have to just implement what has been asked. So here's our string ABBA, which is our pattern and our string. Now watch this. A is mapped to dog. B is mapped to cat. This B is also mapped to cat. And finally, this last A is mapped to dog. So it will always be like this. This mapping doesn't have a direction, okay? So it's not like A means dog, but B can also mean dog. You get it? It's a one-to-one mapping. So this is a mathematical thing. They've told that it's a bijection, full match bijection. So in both directions, it's not that A can mean dog and A can mean cat also. Or A can point to dog, B can also point to dog. It's like a one-to-one function on both sides, right? For example, square of a number is a one-to-one function. Square of 5 is always 25. There's no other number that it can point to. But this direction is fine, but square root can point to plus 5 or minus 5. So that's not a bijection. That's fine. Bijection means if A is dog, A will always be dog and dog will always be A. So there's no direction in this graph. That's why in the second example, when we see fish, right? Some people would have written the code, they would have seen here fish. They would have mapped A to dog. Then the second time when they visited fish, they would have seen that, okay, fish has not yet been mapped by a pattern, let's map him to A, but A is already dog, dog is already A. So you can't have fish also over here, right? Fish would be wrong. You cannot have fish over here. So false. Unless the mapping is perfect. Wherever there's a, there's a dog. Wherever there's a B, there's a cat. That's it. Wherever there's a dog, there's a. Wherever there's a cat, there's a B. The pattern has to follow it exactly. So we are just supposed to do what is asked. Right? Let's go ahead. First, I know that I need to map these characters to words and these words to characters. So let me make two unordered maps. Unordered map is just a dictionary, okay, in C++. Character to the word. So char to word. Similarly, I'll make one more, which would be word to character, right? That will be given a word and it will return the character that it is mapped to. Again, this is quite a implementation problem. We just have to implement what is asked. Now that's fine. Let's go through each word in the string. So I want to split the string by the spaces to get all the words. So I'm going to use the string stream. In C++, when you pass a string to a string stream, and then suppose cn x and y. Here if I have 4 space 55. So 4 will be stored in x and then 55 will be stored in y. Similarly, I'm making a string stream and I'm calling it words. Now, when I write words xy, 4 will go in x and 55 will go in y. So string streams are a topic in themselves, okay? Yeah, you can search for string stream. Yeah, so this basically x will store the string 1, x will get the value 1, y will get the value of 2. It will just split it by the split into all words. That's it. Okay, that's fine. Cool. Now let me do one thing. For each character, okay, see in the pattern. Each character, okay, take one by one. Now I'll check whether this character already has a mapping. Is this character mapped to a string? So char to word dot find c not equal to char to word dot end. So if it is not found, it will return end, right? So I don't want that. I want it to be found. If it is found, okay. If that character is found inside my char to word map, okay, that means I have that character. Great. Also, one more thing to note over here, I'll have my string word. So I'm taking each character one by one. I'll also take each word one by one. Okay. So where's that? Here. Words, word. That's fine. From the words, like from this cn xy, so cn word. String stream. Cn is a string stream. That's an input string stream. Here, that's an input stream. This is a string stream. Okay. That's how it works. So I'm getting each word divided by the spaces. Now this word is found, then I'm writing nested if, right? But I could use an and, that's fine. If char to word c not equal to word. So when I reach a, my char to word is dog. But when I reach a here, I've got fish. So they're not equal. Immediately, what can I say? Return false. It's never going to be true to make this possible, right? Another thing I have to check is, this word, has it been mapped before? Okay, if this was found, then also this word should have been found, right? So if word to char dot find word not equal to word to, so if this is found, okay, this word is found in my map, then if char to word, if word to. Now, which last time I found it, which character was mapped to it? If that is not equal to the character that I'm getting right now, again, directly return false. Now, if all this is fine, return true. Run the code and see, it will return correctly, right? Now, one thing you might have noticed, what if the length is not correct? Okay, so the code should return false. Right, but it's returning true. So when I take in a word, okay, if it took in a word that was null, so I'm just going to take in the word. Now, how to check if a string stream is empty? This would return false, right? If it returns false, okay, then simply you also return false. This character has no equivalent word. What else? Let's test it on this A, B, B, C. So C is trying to get mapped to dog, but dog is already mapped to A. So that will not work. Right? I'm returning true, but I should return false. Now, dog was already stored, okay, here. Oh, sorry, 1 second. If it was not found, then I just need to store it. Sorry, very sorry. Yeah, after each iteration, I need to store the values, right? Sorry. Yeah, that's fine. So now let's run the test cases. Very important to run these test cases always. Just one more. So here some words are left, right? But this is over. The characters are over. So it should return false. If words are left, that means it would return true here. Return false. Right? String streams are very useful in C++. And I think I can submit the code. So bijection, check if this character maps to the word correctly. Check if this word maps to the character. You don't even need to think about the unordered map since they've told you that it must match. There's a bijection, so each character must match one word and each word must match one character. Thanks for watching, and yeah, that's it. Let's keep going on. Bye bye.